So for our second example, we have that in a survey of 800 people aged 18 to 29, 50% said they got their news online. And we want to construct a 97% confidence interval for the percentage of such people. What an odd number. Here we have that since the values are the same, n p hat is going to equal n q hat because p hat equals q hat equals 0.50, we will end up with 400 in both cases, resulting from n being 800, but importantly, these are both considerably larger than 5. Like I said, this is kind of like the steps with the central limit theorem and the other problems. If it doesn't happen, the whole question doesn't happen, and since I want you to get practice with this, it's going to happen most of the time. But, you know, you gotta be sure. And it's good to build that habit in there if you're ever gonna do this stuff for yourself. Anyway, we have what we need, so from there, if we want to get E by hand, just to be sure, E is equal to Z sub C times the square root of P hat Q hat over N, just like I have right there. Or, in this case, since we want a 97% confidence interval, what an unusual Z-score that's going to be. We will have 0.217, it's an oddball to be sure, multiplied by 0.5 over 800 inside of a radical, which gets a margin of error of about 0.038. That is just under 4%. So if we want to make our confidence interval, we will take p hat, 0.5, subtract from it 0.038. Know that p is in the middle of that, and that same value plus 0.038. Plug those in, pull those out, and we get our interval from 0.462 to 0.538. That is, we are 97% confident that the proportion of people from ages 18 to 29 who get their news online is between 46.2 and 53.8%. Where if we want to, this type of computation can be done just as well in the calculator from scratch, where for that one I did a slightly different computation, so I get a slightly different number. But hey, it's good to get a range of options here, isn't it? But this is one way we can handle it. This is one type of problem we can see. We're going to finish this with one more type of problem, where we'll look at how we can twist these types of things around like we did in 6.1 to talk about minimum sample sizes.